Hey everyone, welcome back. So if you are joining us from our part 1 lesson, this would have been the bell ringer for the next class. So I'm just gonna go ahead and I want you to go ahead and try them, pause the video, give them a shot. Just to check your work, you should have ended up with, this is the difference of squares, so x minus 3, x plus 3. The second one is x plus 3, x plus 3, which would be x plus 3 squared for simplicity's sake. And then the bottom one would be x minus 3, which would be x minus 3 squared. So looking at those, they are going to come back and talk. We're going to come back to these later in the class, actually. But just as a reminder, factoring never goes away for us. We are going to head and start with end behavior. We kind of touched this last class, or the last lesson, when we looked at the errors of the graph. So when we're doing this, we actually have two choices, for it all depends on where the arrows. So I do want you to go ahead and try these. Just remember that the top one is to the left arrow, the bottom one is the right arrow. So as you're graphing them, so for example, if this was my graph, I would say the left arrow is going to negative infinity, the bottom arrow is going to infinity. If you had one that looks like this in some sort, we would say they both go to negative infinity. So I do want you to go ahead and try those on your own and then come back and check your work. All right, let's go ahead and check your work. So our first one here is going to be positive infinity, positive infinity. Number 2 is negative infinity and negative infinity. Number 3 is negative infinity and positive infinity. Number 4 is positive infinity, negative infinity. Number 5 is positive infinity, positive infinity. And number 6 is negative infinity, negative infinity. So just checking your work. Again, you're supposed to graph these, but we're going to take a look at how to do these without graphing them is the goal today. So if you have the handout, we're going to fill out the table. When written in standard form, the leading coefficient and degree of the polynomial function determines the end behavior of the function. So when we're looking at this, and this is actually true for any, even if it's not in standard form, it's just the leading coefficient's not at the front. So when we're looking at anything, we have a term, so we're gonna say this is my term. As a reminder, the number at the front is called the coefficient. We have the number up here is our exponent. And this overall is called a term. Now the term with the highest exponent is the one that determines the degree. The leading coefficient is always attached to the highest degree. So even if it's not in standard form, find the highest number for the exponent and find the leading coefficient attached to it. So if my exponent is even, so we're just going to review that. Even is any number that ends in 2, 4, 6, 8, or a 0. Odd is any number that ends in a 1, a 3, a 5, a 7, or a 9. So that's how we're going to be able to tell even and odd. It's not a trick. And if the leading coefficient is positive or negative, those are my only two choices. So if it is even and a positive leading coefficient, the graph is going to point up in both directions. So my end behavior would be positive infinity, positive infinity. If the leading coefficient was negative, but I have an even degree, both arrows are pointing down. So we go negative infinity, negative infinity. If my degree is odd and my leading coefficient is positive, on the left we go down, on the right we go up. So we're going to go from negative infinity to positive infinity. If the degree is odd and the leading coefficient is negative, we start on the left going up, and on the right we go down. And so we go positive infinity to negative infinity. Now there are a couple things that if you can take a look, notice that the positive, when we have positive, that the right arrow is positive. When we have negative, the right arrow is negative. So you are able to actually tell the leading coefficient from a graph based on what the right arrow is doing. I may not be able to tell you the exact value of the leading coefficient, but I can tell you whether it's positive or negative. And that is very important to us as we're going through this and reading through some of these problems. So we're going to use the chart we just made, and really we're going to do 7 through 16. We're going to answer the problems without a calculator. So we're going to take a look at number 7 together. So number 7, and these are actually all in standard form, so it's the first term in each of them. If I do not see an exponent, there is an exponent of 1. So in this case, my degree is 1. My leading coefficient is -5. So that means I have an odd negative, which would tell me that my graph goes up first and then down. So that's how we're going to fill it out. I do want you to go ahead and try the rest of the problems. Again, if you don't have the handout, go ahead and do 7 through 8 first, and then I'll switch to the next slide so you can see the rest of the problems. So go ahead and try 8 and 9. All right, let's take a look at 8 and 9. So looking at 8, my leading coefficient is 12. My degree is 2, so that is even and positive. So that means we're going to go up, up. I am writing the number I'm referring to make sure that we're all looking at the correct number. For my number 9, my degree is 3. My leading coefficient is -1. So that is odd negative. So that would be up, then down. All right, let's go to the next slide. So I want you to go ahead and pause it and go ahead and try 10 through 14. All right, looking here at number 10, my degree is 4. I'm just actually going to do the degree for all of them. Degree for 11 is 5. And then we have 4, 7, and 2. So these are my degrees. So this would be even, odd, even, odd, even. Next, for my leading coefficient, we're going to have -3, +9, +5, -1, and -3. So this would be negative, positive, positive, negative, and negative. So based on my chart, even negative tells me down, down. Odd positive tells me down, up. Even positive tells me up, up. Odd negative, down, up and down, and then negative, even, and down, down. I find it's easier to do the right arrow because it's going to follow whatever the leading coefficient is. And then on odds, I just need a different one. I need the opposite. On evens, I need the same. All right, looking here at 15 and 16, we're going to do the same thing without a calculator. Determine whether the sign of the leading, what the sign of the leading coefficient is. So again, this is it positive or negative? And then determine if the function is even or odd. So let's take a look at 15. I'm looking at my arrows, and then my arrows are down, down. So my chart would tell me that this is an even negative function. So based on that, I want you to go ahead, pause the video, and try 16. All right, let's take a look here. So we have down to the left, up to the right. So that's down and then up. So I can tell you that it is odd because opposite directions, and that it is positive. So it's an odd positive function. So nothing too crazy, and behavior is actually very straightforward. Nothing, we're not trying to trick you or anything. But let's go ahead. So without using a calculator, if I gave you the end behavior, could you determine which functions could possibly work? So let's take a look at 17 together. 17 has, again, we're looking at here. So 17 is down, down. So based on my chart, I know that is a even negative. So all we're going to do is we are going to look at this first term on all of them and see if they are an even exponent with a negative coefficient. So because of this 3, that does not work. The 3 is positive here. Both of those work. Those both don't work. The 7 doesn't work. Both of those work. So the third and the last. So when you go ahead and pause the video and go ahead and try number 18. All right, let's go ahead and check your work. Again, we're only looking at that first term. So I can see it goes down, then up. So this would be an odd positive function. So both of those are wrong. This one works. This one works. That's negative. That's both of those don't work. So the second and third one. Go ahead and try 19 and 20.
This is the NPA lunch.
So again, go ahead, try 19 and 20. All right, let's go ahead and check your work. So on 19, we have up and then down. So this is a negative odd. So the first one, the third one, not the third one, I'm sorry, the fourth one and the last one. On 20, we have up, which would be a positive even. So the second one, the fourth one, and the fifth one work. So that is our end behavior. Nothing too horrible. If you have the handout, I do want you to go ahead and try this one. This would be kind of like the midpoint check. If you don't, I would like you to go ahead and try it, and I'll just go ahead and go over the answers really fast once we finish it. All right, so for those that did go ahead and give this a try, here's what we would have. Here is our graph. The parent function is going to be x cubed. My domain and range is all real numbers. The parent function is based on what the degree is. Our turning points are at negative 3.15. This is a max and 3.08. We have a minimum at negative 0.845 and at negative 3.08. It is increasing from negative infinity to negative 3.5 and negative 0.45 to infinity. It is decreasing from negative 3.515 to negative 0.845. I have zeros at negative 4, negative 2, 0. And my end behaviors, as we go to the left, the graph goes down to the negative infinity. As we go to the right, it goes up to infinity. And for those that were able to do it. I could go ahead. I'm going to skip this one. So zeros and multiplicity. So for zeros, we have, for some of you who took Algebra 1 here with us at Skyline, there was an acronym they gave you, ROCKS, which stands R is for roots. The O is for zeros. X for x-intercepts. If I could spell. And S is for solutions. So the zeros, the O is an actual zero, is what we use this. So just as a reminder that when we say zeros for anything in a function, we're talking about pretty much the x-intercepts. The vocabulary word they give you, whether it's a root, a zero, an x-intercept, or a solution, is based on the format they give you the question from or what information is already given to you. So zeros are the point at which the function intersects the x-axis, hence it's an x-intercept. A polynomial function of degree n will have at most n real zeros. So what we mean by that is if I have x squared, then that's the one I'm going to refer to because we have the most examples of that, is that we said I can have at most 2 times for it to cross. It's only going to cross twice. I can't cross more than that. I can cross less, but not more. So for like a cubic, the most it could cross is 3 times. So this is a cubic. At most, it will cross 3 times. It might cross less than that, but at most, it will cross that much. An even degree polynomial is going to have an even number of zeros. This is going to include what we call a double root. And again, I'm going to use like quadratic as an example. So if you recall, sometimes our vertex was on the x-axis. So this counts as a double root. So it is going to count twice. And that is the same thing even on odds. If it was so here's my cubic. I can pretend I touched that, so I'm gonna put a really big dot. So an odd degree polynomial will have an odd number of zeros. Again, this root that's on the axis counts twice. Or at least twice. So again, this is technically one, this is 1 and 2. This is 1, 2, and 3 for when we count our roots. So this here would be 1, 2, 1, 2. But yes, if it touches on the x-axis and then what we call bounce is away from the x-axis, it is going to count as a double root. So if we were to graph these using the school calculator, we would do menu 6-1 for zeros on Desmos and automatically marks them for us. So here we have x cubed plus x squared minus 2x. So we would graph this in Desmos first. So I'm actually going to answer the rest, these part of the questions on Desmos. Because for those of you who know what the room looks like, me going back and forth between the screen and the computer is quite a walk. Or not really, but for the sake of time of the lesson. So let's go ahead and go into Desmos. For those who need to see it actually once in the school calculator, press and hold delete. Yes, delete everything. Tab to add a new one. So I'm just going to do this first one in the school calculator so we can see it. Oops, and we do want to make sure that you step out of your exponent. For those using the school calculators, I want to stress the importance of using the white minus button over the black negative button for these minus signs. If you don't use the correct one, your answer will not look correct. So here's my graph. As we graph it, I can see it touches only once. I would do menu 6-1 before and after. So here is my root. X cubed minus 3x squared minus 3. So at 3.8 comma 0. If I was to do it here in Desmos, x cubed minus 3x squared minus 3. Again, same thing. We're just going to round to 3.8, 3.28. I just realized I graphed the wrong one. So let me redo that one. This is supposed to be x cubed plus x squared minus 2x. I'm sorry about that. So here's what it looks like. Helps if you graph the correct one. So we have 3 zeros at -2, 0, 0, 0, and at 1, 0. So for for this part, I would write it as, we're just not. I'm not as good anymore with that, so we're still like, but that's how you would do number 1, and you would graph it. It just says identify the number of zeros. So go ahead and try number 2 and see if you can identify the zeros. All right, let's go ahead and check your work. For number 2, you should have graphed negative x to the 4th plus 5x squared minus 4. So my zeros are at -2, 0, -1, 0, 1, 0, and 2, 0. Those would be my answers. So it is nice that you can actually add these. So these are my answers right here. Moving on to linear factors. The linear factors of a polynomial reveals its zeros. Linear factors can be found by writing the polynomial in factored form. If x minus a is a factor of f of x, then a is a 0 of f of x. All right, so without graphing, we're actually also able to answer these. Again, as I told you beforehand, factoring is not going away. So let's go ahead and take a look here. I would look and notice that they all have an x, so we're going to factor out an x, which leaves us x squared minus 2x minus 15. So we're going to go ahead and factor that. So I could do an x here, negative 15 up top to multiply, add up to -2. So we have 3 and -5 because they multiply to -15, but add up to -2. So this is going to factor into x plus 3, x minus 5. So that would be my factored form. So when we're solving for the zeros, we're going to go ahead and set each factor equal to 0. So this first factor, x equals 0, so 0 is an answer. X plus 3 equals 0, so I'm going to subtract 3. And we get x equals -3. So I'm going to do -3. X minus 5 equals 0. Add 5. And x equals 5. So this is an extension of our quadratics when we would solve quadratics and find the zeros. So that is the review from there. So the expectation is that you are pulling back that information from last semester. Moving on to part 4, or question 4. Right, multiplicity. The multiplicity of a zero is equal to the number of times it corresponds to the linear factor occurs. What we're talking about that is when my best example is the bell ringer. And we said this would be x plus 3 squared. So this would mean that x equals -3 happens twice. So this would have a multiplicity of 2 because it happens 2 times. All right, so our factored form, we're going to start off by factoring out an x. And we're left with x squared minus 6x plus 9. Now, if you paid attention to the bell ringer that I gave you, I did say we were going to come back to that, and I can automatically just say this is x minus 3 squared. Because we did do this question in the bell ringer at the very start. I do have 2 zeros, so we're going to set each factor equal to 0. First one's done. Second one, we need to add 3. So we get x equals 3. So x equals 0 with a multiplicity of 1, because it only happens once. And then x equals 3 with a multiplicity of 2, because we have the exponent. Your exponent here is going to tell me my multiplicity. Same thing on the outside for this one. This actually has an x to the 1. That tells me my multiplicity. If I can spell, so my multiplicity is my exponents. So what I want you to go ahead and do is I want you to go ahead and graph x cubed minus 6x squared plus 9x and put it on the graph that's provided. So we just say at 0 and at 3, 1, minus 6, 9, so 10, so 4. -1, -6. It's gonna look something like this, not too exact. I'm not that concerned on how close I am to this one. But I do want to take a look at my zeros. Here is my 0, x equals 0. Here is x equals 3. So notice that the multiplicity, when it is odd, like it was at 0, it will cross at that 0. If the multiplicity is even, then the graph will bounce at that 0. So I want you to go ahead and try 6 and 7. To identify the 0, the multiplicity, and its effect. 6 is the easier one because it's already in factored form. 7 has you practice your factoring. So go ahead and pause the video, give those two a try. All right, let's take a look at number 6 together. I'm going to set all my factors equal to 0. So x plus 7 equals 0. 2x plus 1 equals 0. And x minus 4 equals 0. So over here, we're going to subtract 7 from both sides. And we get x equals -7. Subtract 1, subtract 1. 2x equals 1, divide by 2. Oh, this should be a 0. I'm sorry. So this is a -1. Divide by 2, x equals -1/2. And over here, plus 4, x equals 4. I like to list my zeros in numerical order if possible. So we're going to do -7, -1/2, and 4. -7's multiplicity is 2. And so when that is even, so that tells me it's going to bounce. 1/2 has a multiplicity of 1. So if I don't see an exponent, the exponent is 1, so that's odd, so it's going to cross. X to the 4 has an exponent of 3, so that's my multiplicity, so it will cross. On number 7, we're going to factor out a -2x squared.
Hello, Starline. Today we are having the Senior Black Health Fair.
So we're going to go ahead and continue factoring.
Friendly reminder, the blood drive is going on at the Mayo Gym, so please go donate your blood if you signed up. Today we have with us the Black Heart Association, and we would love for you to come get your health clinic.
So each factor equal to 0.
If you would like to come down, the Black Heart Association. We're screening to see the risk of you having a heart attack or stroke, and we're also screening
Go ahead
for
and solve each factor
cholesterol.
equals to 0.
We hope to see you soon. Do we have anybody that needs to register to vote? Come to the health fair. We have Black Lives Matter come to register for voting. So they're always going to be happy here at your Scotland. Come to the health fair, get your health screened. We also are giving away free books. So come get your white pink book as if you will at book fair. I mean, not the book fair, the health fair. Somewhere down. Bye. We're located in the student center.
All right, sorry about that. So again, your factor, and set each factor equal to 0. -2 has a multiplicity of 1, so it will cross. 0 has a multiplicity of 2 because this exponent on the outside is a 2. So that means it will bounce. And then 4 has a multiplicity of 1, so it will cross. Okay, pause the video as needed, but we're going to go ahead and take a look at question number 8. Oh, look at that. I didn't realize I had these filled in. So if you still didn't get it, I did include the factoring by grouping in this one, so for those that needed to see it. Moving on to number 8. Is this one? A polynomial function has a 0 at -6, multiplicity of 2, and 2, multiplicity of 1. Write a polynomial function in standard form that can represent this situation. So this is just us going backwards from what we just did. So this is saying that I have x equals -6 with multiplicity of 2, x equals 2, multiplicity of 1. So that would be x plus 6 squared times x minus 2 to the first power. So we would go ahead and expand it out. So those first two, if I did my box, we would have, this would be the box I get because we can fill it out by multiplying. We would have x squared plus 12x plus 36 times x minus 2, which gives us another box. And we're filling it out. And we get x cubed plus 10x squared plus 12x minus 72. This would be of the least form, meaning that nothing else special is happening going on here. So you do have a DOL, is go ahead, graph this function and tell me the type of function it is, the domain, range, and behavior, turning points, relative min, max, zeros. So you can go ahead and give that a shot and then come ask me about that one, or if you would like to check it later on, you can. But I guess we can go over it really fast. Yeah, I guess we've talked about it. All right, so hopefully that was enough time for you to try it. If not, pause the video. So looking at this, I can tell you that this is a cubic with a parent function of f of x equals x cubed. It is a positive odd function. So my end behavior would be as x approaches negative infinity, f of x is going to approach negative infinity. As x approaches positive infinity, f of x will approach positive infinity. My domain and range is all real numbers. Zeros, I don't know, the question is, if I group these, let's see if I get nice answers for my zeros. So I'm gonna pull out x squared, I'm left with x minus 10. Nope, I'm not gonna get nice zeros doing it that way. So we are gonna go ahead and graph this and find the zeros and turning points using Desmos. So I'm just gonna go ahead and do that and then just check your answers. So x cubed minus 10x squared plus 28x minus 24. It's because of that, got it. All right, so my zeros are 2, 0, and 6, 0. with 2 having a multiplicity of x equals 2 with multiplicity I can spell. 2 x equals 6 with multiplicity of 1. My turning point, I have 1 turning point. I have a relative, my turning point is at 4.67 comma negative 9.48, and this is a relative, I have 2 turning points, I'm sorry. This is a relative min. I'd have another turning point is at 2, 0, and this is a relative max. Anything else that I might want to include? I could tell you that my y-intercept, that this is not something we've gone over, but I do know my y-intercept is at 0, negative 24. That's another thing about the graph that you could tell me. But that is everything about the graph, and it looks gonna look like that. Do that. Let's do this. So here is this. So here's what my graph looks like. With my turning point. That's what it's look like. So for those that want to try it, there you go. If you didn't want to, again, thanks for listening. But if you have any questions, do let me know. But that is everything, and I'll see you guys next time.